All right, cool. So this is Cooking with AWS. My name is Josh. I work at Amazon Web Services. As mentioned, we have a very tight time frame, so I'm going to be trying to move pretty quickly. This is my dating profile here. I'm a partner solutions architect currently at Amazon Web Services. I cover DevOps partners like Chef, so that's kind of why I'm here today. Just real quick, I'll run through the agenda, what I'm going to talk about, and how this talk will kind of go. So first, I'm going to briefly introduce and talk about AWS and Chef and the partnership and kind of why I'm here today. Then I'm going to cover a couple ways that you can take advantage of using AWS services to help improve your usage of Chef on AWS, well, hopefully. And then for each of these, I'll kind of introduce a use case. I'll talk a little bit about the AWS services that are in use. That way we're all on the same page. And then I'm going to do some demo. I'm going to try to do about 20 minutes of demo, 10 minutes of slides, because looking at slides is super boring. All right, so AWS and Chef. Again, I just want to take a couple minutes to talk about why I'm here today. I promise I only have a couple of sales pitchy slides, and then we'll get to the good stuff. Okay, and with that, I present to you Josh's 3-step guide for running a successful company. Coincidentally, Amazon Web Services helps your business do all three of these things. So AWS helps you trade capital expense for variable expense. We all understand probably the value proposition of the cloud, so you can pay for IT resources as you need them, when you need them. AWS also helps you reduce the need to do capacity planning and procurement for resources like storage and compute. So instead of waiting weeks or months for procurement and racking and stacking, you just get it instantly. Finally, you can deploy to our 13 regions or 35 availability zones. We just launched India a few weeks ago in minutes. And so instead of maintaining data centers and infrastructure and all that boring stuff, you can focus on what your company does best to differentiate. AWS also has a very robust platform of over 70 services now, and something that customers tell me often when I go to events like this is they absolutely love our pace of innovation. And so what I mean by that is last year in 2015 alone, we released 722 new features and services. So you heard that right, 722. This year in 2016, as of April, we're already over the 200 mark, so we're kind of continuing that. And so what this lets you do is innovate at startup-like speed. And again, believe it or not, AWS helps you reduce risk thanks to our over 50 compliance certifications and everything that goes involved in obtaining those, like best practices and procedures and architectural decisions we make that even our most security-sensitive customers require. So everybody gets the benefit of these, which is awesome. And then, of course, we have native tools and functionality for things like encryption, network security, identity management, and industry-leading security professionals behind all of that. Okay, at AWS, we believe cloud is the new normal. So what do I mean by cloud is the new normal? It's not just startups on AWS like Pinterest or Netflix or Spotify. We have customers of all shapes and sizes, literally in every industry, running every imaginable workload you could possibly think of. And in particular, we're seeing a large trend of big enterprise companies moving and migrating to AWS or even going all in on AWS. And so there's a couple quotes on the screen there. The one I'll call your attention to is the bottom one. It's a quote by Rob Alexander, the CIO of Capital One. And he says, "We work closely with AWS to develop a security model which we believe enables us to operate more securely in the public cloud than we can in our own data centers." So to me, that's a pretty powerful statement, and again, a testament of how the cloud is the new normal. Okay, so you might be asking yourself, why are you here? Why is AWS here? So again, not only is Chef a very important partner to AWS, customers like you guys that use Chef and AWS are also extremely important to us. So that's why I'm here today to talk about a few things that can help our mutual customers out. And I just have one quick slide where I'll spend on information about migrations, because I think this is particularly important. So first thing I'll call your attention to is the AWS Marketplace. So if you're not familiar with this, it's just an online store that makes it super simple for customers to find, purchase, and deploy solutions into their AWS accounts, such as Chef Server or Chef Compliance. So it makes it really easy. It's a Chef-blessed installation. You get your billing all in your same AWS account automatically, which is really handy. We also have AWS Quick Start, which is like a template and documentation that helps you get Chef Server up and running. This is more of a bring your own license model. So if you don't want the billing for your Chef Server to go into your AWS account, you can continue to use existing Chef licenses. Then we also partnered with Fast Robot to create kind of a handy little guide and some sample cookbooks for getting up and running on AWS quickly with Chef. And of course, we have AWS OpsWorks, which is our managed configuration management server powered by none other than Chef. And then finally, I just want to leave one last pro tip on there. If you're going to do a migration, and let's say you're a new Chef customer as well and you're migrating to AWS, please write your cookbooks first. If you migrate your workloads and then install Chef and write cookbooks, you literally just did twice the work. If you write your cookbooks first, you can get your migration all in one. Okay, now that we made it through all of that, I'll talk about my first use case of how we can use some AWS services to do solve kind of like a known problem around AWS and Chef. And so that's automatically cleaning up terminated AWS instances in your Chef server. So most people are probably in this room familiar with autoscaling on AWS. So if you're not familiar with autoscaling groups, basically what autoscaling on AWS and other cloud providers in a similar fashion allow you to do are scale up or down parts of your infrastructure dynamically based on some kind of policy or rule set. So for example, let's say you have a website, you have a group of servers that run your website, traffic's increasing, now you want to automatically scale out. So you can set up a policy that says like, when I hit X amount of utilization, I want to automatically scale out. And then when traffic subsides, I can say shrink back in, so we lose those servers automatically. And so the problem is with Chef server, if your nodes get terminated, they don't automatically go away for you. So now this is like a manual cleanup step that you have to do in Chef server. So you might have just nodes hanging around, or if you have Chef Enterprise, you're consuming licenses. So using just a couple AWS services, we can actually automate this. And so the services that we're going to use for this, and again, I'm going to demo all this and walk you through this, is AWS Lambda, Amazon CloudWatch Events, and AWS Key Management Services. Okay, AWS Lambda. Real quick show of hands. Who's heard of Lambda, first of all? Let's do that. Wow, awesome. Who's actually used it? Maybe something in production. Okay, so about half the people that raised their hands. In my opinion, I'm 100% comfortable saying if you walk away from anything with this session, you should go play with Lambda more, because it really is that cool. It's totally, in my opinion, going to change the way we think about computing. And so just to kind of real quick talk about it, Lambda, you can think about, it's a way for you to run code without managing any kind of servers or infrastructures. So you heard that right. You literally don't have to worry about managing any kind of underlying infrastructure. You just upload your code. The service handles scaling it. It handles high availability, everything around managing and maintaining that code. And so you can set up your code to automatically get triggered from a few different sources or AWS services. And you can also call it directly. So you can, from any web or mobile application, you can just call that Lambda function directly. So in our case, for the purposes of all of this, we're going to write a Lambda function in Python that removes a node from the Chef server automatically when when an instance gets terminated. Okay, and to help us do that, we're going to use Amazon CloudWatch Events. So CloudWatch Events is also one of my new favorite services, mostly due to the ability to use it in conjunction with Lambda. And so what CloudWatch Events allows you to do is create a simple rule that matches an event and then routes it to one or more targets. So an event can be something like an API call to another service, either through the RESTful API or an SDK, or it can be something like an instance state change. So maybe when an instance goes from running to terminated. And a target can be something like an SNS topic, an SQS queue, or a Lambda function. So it's probably starting to make a little bit of sense now. We'll use CloudWatch Events to create a rule that when anytime an instance gets terminated, we'll fire off a Lambda function to do our actual cleanup. And then to tie it all together and make sure we do this securely, we're going to use AWS Key Management Service, or KMS. The hard thing about encryption is really managing the keys. And so what KMS is, it's a managed service that makes it easy for you to create and control your encryption keys used to encrypt and decrypt your data. So nothing gets stored in KMS, it's just simply a key management service. And so we're going to use it to encrypt a copy of a private key or a private certificate that we'll use to authenticate to our Chef server. And so each time our Lambda function gets called, we'll go ahead and decrypt it on the fly in KMS, and then we'll securely authenticate to Chef server. Okay, let's do some demo. Okay, so as I mentioned, we're going to write this in Python. So Lambda supports 3 languages today. So we support Python, Node.js, and Java. And for Java, that can be any JVM-based language like Clojure or Scala, if that's your thing. Each supported language, we also have an AWS SDK associated with those and several other languages. But with Lambda, out of the box, you will get support for the SDK of the language of your choice. So in my case, I'm going to use Bodo 3. I don't know if the highlighting will show up well there. So I'm importing the Bodo 3 SDK. You can import third-party modules or other libraries too with your code. So you're not just limited to the code that you write or the code that's available to you. So you can package everything up in a zip, upload it to Lambda, and all your libraries and everything you need, your dependencies are all there. You might be able to see on the left-hand side, I got a bunch of dependencies with this, including PyChef, written and maintained by Code Ranger. I don't know if Noah might happen to be here, but if he is, thank you so much for that. So I'm using PyChef along with this. So I'm importing a few things, just setting up a few local variables to be used here. The first function is this log event. This is mostly uninteresting, just some debugging stuff. But the first interesting function in my code here is this get instance ID. And this is important because the way CloudWatch Events works is it passes a JSON object with a bunch of metadata in it to whatever your target is. So in this case, when I get my Lambda function fired off by CloudWatch Events, I'm going to get a JSON object with a bunch of things in it, including an instance ID. and I have an attribute in my Chef server with that instance ID. So that's what I'm going to query my Chef server on to find that node to delete it. The next interesting function in here is this get pem. And so this is going to do my call to KMS to decrypt my encrypted certificate, so that way I can securely authenticate. This is dead simple to set up. So I'm just reading in that encrypted file. Actually, here's what the encrypted file looks like. Right now, it's base 64 encoded. Scroll back down. OK, so here I'm just setting up a Boto3 client calling the KMS service. And then all I'm calling is the decrypt method and passing it in that encrypted certificate. Literally, that's it. KMS returns the decrypted secret back to me. Super easy to use. Then on this handle function, this is like the equivalent of main, basically. You can think about it as. So in main, all I'm really doing is I'm calling Chef API using PyChef, passing in my now decrypted credentials and some other parameters like my Chef server. I'm getting my instance ID from the JSON event. I'm searching for that instance ID in the Chef server. If I find it, I delete it. If I don't find it, I do nothing and I move on. The Lambda free tier is actually extremely generous. You get 1 million invocations free per month. So this is extremely cheap to set up as well. OK, let's jump into the console real quick. So this is what the Lambda console looks like. You'll see here there's 4 tabs across the top when you're actually looking at a function that already exists. The first is code. So there's actually an in-browser code editor. You don't see it right now on this one because, again, I have a bunch of third-party modules in there and stuff. And so when you have more than one file, you actually don't get access to the in-browser editor. But let me just show you what one looks like if you do. It's probably hard to see because the screen's quite stretched. But it's simple. You get some nice syntax highlighting. It's pretty basic, not a whole lot of frills, but it does work. It's functional. You can test in the browser as well, which is pretty cool. OK, let me go back and open my Lambda function. All right, the next tab is configuration. So again, this is where you can pick your runtime, Node.js, Java, Python. And then you assign an IAM role, or Identity and Access Management role. And this is our permissions system through AWS. So this allows you to give really fine-grained access to your Lambda function, just like you're used to doing with pretty much every AWS service today. You can tell the Lambda function exactly what it has access to, all the resources, all those different things. And you can enter a description, of course. OK, so under advanced settings. So some of you might be wondering how much compute power do I actually get with a Lambda function? So the key is you assign amount of memory to your Lambda function. And you'll notice on there, there's no tab or there's no drop-down box for compute or networking capacity through there too. So those come proportional to the amount of memory you actually give your Lambda function. So for example, there's 128 megabytes is the lowest amount of memory you can give, with 1.5 gigabytes being the most, and it goes up in 64 megabyte increments. So if I give my function 512 megabytes of memory, I'm going to get more compute power out of that. And I'll show you in just a moment how you can actually go about sizing your Lambda functions a little bit better. So we give you some built-in tools to do that. And then there's a timeout value. So I believe the maximum timeout for Lambda is 5 minutes now, but you can set your appropriate timeout value there. And then if you need VPC support, so maybe your Lambda function needs to talk to a resource in an RDS database that's in a VPC or some other EC2 instance in a VPC, this is where you would set your Lambda in a VPC. OK, triggers. This is how your Lambda function gets invoked. You can actually add multiple triggers for a Lambda function, so there's more than one way you can invoke it. You can see here that I have a CloudWatch events trigger set up already. There's other triggers you can add, though, like, for example, maybe you want to call Lambda anytime a DynamoDB table receives an update. Or anytime an S3 bucket has an object placed inside of it, you can run a Lambda function. So there's a few other things on there, and we're adding more and more support for our other AWS services. OK, finally, monitoring. So you can see we give you a little monitoring here. You can see the invocation count. You get a little chart of the duration. But really, the cool thing to pay attention to is there's a nice little link in there for view logs in CloudWatch. So CloudWatch is our service that streams logs from various services to there. And so out of the box with Lambda, you'll get a log stream of anything your Lambda does, capturing all the standard out and standard error. And really, actually right here at the top, this is very convenient. At the end of every single Lambda run, it might be kind of hard to see. Let me blow it up just a little bit. At the end of every single Lambda run there, you get some nice information about the Lambda. You see exactly how long it ran. So in this case, it ran for 1101.25 milliseconds. And it used 31 megabytes of memory. So this is, again, how you can size your Lambda a little bit more appropriately. Let's say you give it 256. It's hitting 256 and taking like 40 seconds to run. Well, you probably want to bump it up a little bit. So this is a nice way to actually look at that a little bit. OK, CloudWatch events. Get that down. OK. So CloudWatch events, this is the console for where you see your different rules. You can see I have 3 set up there, including one for the Chef node cleanup. But let's create a new one so you can actually see how it goes. So it's super simple. You pick an event. And inside the event dropdown, you have instant state change notification. So again, maybe entering the terminated state. Schedule. Schedule is awesome. It's literally like a cron job, so you can replace worker nodes and job nodes with Lambda functions. Really cool. AWS API calls. So again, almost any API call across any other service, you can trigger a Lambda function in response to or do something else using CloudWatch events. And of course, auto scaling. So I'll just pick state change. I'll select specific state and then terminated. And so this is any instance at all that hits the terminated state. And then our target, you can see we have Lambda function, SNS topic, SQSQ, Kinesis stream, and built-in target. Built-in target is a little vague. It's basically just synonymous with CloudWatch alarm. And so we can pick Lambda function, enter the name of the Lambda function, and we're good. You'll also notice that you can do multiple targets. So you can run things in parallel from CloudWatch events, which is pretty handy. OK, next I'll talk about KMS real quick. I'm just going to do a brief demo of how you can actually encrypt and decrypt something using a master key. So the KMS console, there actually is no console named KMS. You have to go to IAM, or Identity and Access Management. And in the console there, you'll notice in the bottom left, there's this encryption keys. So you just click that, and that's KMS. All right, so I'm going to hit create key. I'm just going to call it ChefConf 2016 demo. You can give it a description. So this is creating a new customer master key. The first thing you do is assign some administrative permissions to the key, basically who has access to modify permissions to a key and do things like check out the auditing. So let's see, I have an admin role, so I'm going to add my admin role. The next step, which looks suspiciously like the first step, is actual key usage. So this is the user or role that has the ability to encrypt and decrypt. So this would be like an application, for example. In best practices in the real world, you want to make sure you have a different role or user for every application. That way you're limiting your blast radius if you do have a key compromised. So just keep that in mind. So I'm just going to select a user here. I'll click next. It shoots out the IAM policy just to look at. And then we'll hit finish. So it creates my key. And then once the console loads, let's see, ChefConf demo. So we'll click on that. We're going to get a bunch of information back here. So the summary we see, make this a little bit bigger, an Amazon resource name with the key ID up there. Again, our key policy where we can modify it. You can set it to automatically rotate every year, which is pretty nice. And then an audit. So once it's used, you can actually see the audit trail of exactly who used it, who called encryption, who called decryption. You can see exactly what it's doing, which is really nice. OK, so what I'm going to do is I'm going to copy the key here. And then I'm going to go over to my handy dandy cheat sheet. Paste some stuff in here. This is way easier than typing out really long commands. OK, so the first command I'm going to run, I'm using the AWS CLI tools for OS X, by the way. And so I'm just calling the encrypt command here and passing in a few flags like region, because that's where the region where my key is in. That key ID you saw me just copy paste, and then a plain text file. So I'll quickly, let me show you this plain text file. It just says, hello, ChefConf 2016 with a lot of excitement. And so, oops. OK, let's try that again. All right, so if I run that encrypt command on that plain text file, you see I get back a JSON response. And one of the keys in that response is ciphertext blob. And so this is an encrypted and base64 encoded representation of that plain text file that says, hello, ChefConf. Now, if I go back over and grab my next cheated command, actually, let me do. So this time, instead of just dumping the output to the screen, I'm actually going to write it to an encrypted file. So this is a binary file. If I open this up, it's called kmsdemo.txt. You can see a bunch of garbage in there. And now that's my encrypted file, my hello ChefConf file. And so the last thing I'll do is now I'll decrypt it. And this time I'll pass in that encrypted binary file. So I'm calling KMS decrypt. Again, the region, the ciphertext blob, which again is a binary file, and then a couple other flags in there to actually dump the output to the screen. Base64 decoded so we can read it. And there you go. So hello ChefConf 2016. So one interesting thing to note is you'll notice in my decrypt command, I did not pass in a key ID. And that's because the key ID is actually embedded in the encrypted file. So just one quick thing to note there. OK, cool. So we've walked through all the parts. Now let's actually see it in action. So here's my Chef server. Let me refresh it here so you know I'm not pulling any tricks on you. I have 4 nodes in there. There's 2 Windows boxes and 2 Amazon Linux instances. Let me go over to my console here, refresh this. OK, so here's my 2 Linux boxes. I will terminate them. And again, this doesn't have to be manually terminated. This could be auto-scaling event terminated, or something else deprovisions it. Any reason that at all these instances get terminated, this process kicks off. So again, just to recap, we're going to have a CloudWatch event that gets fired and trigger a Lambda function. There's actually going to be 2 Lambda functions that get invoked because there's 2 instances that were deleted. Each one will have the instance ID within that JSON object. So my Lambda function will grab that instance ID. It'll call to KMS to decrypt my encrypted certificate, and then it'll authenticate to Chef server securely, find the node, and delete it. All right, so hopefully in that 5 seconds of talking, these have now transitioned to terminated. Let's take a look at the console. Oh, we got one. Oh, let's see. EC2 is just messing with me now. All right, this one's probably still transitioning from running to terminated. Okay, so they're both gone now. Okay, well, one of them is not terminating yet, so it's probably still transitioning. You'll have to take my word for it. I promise it works. This is, again, live demo. Gotta love live demo. Okay, actually, and before I do this, now I gotta spin my nodes back up for the next part of my demo. I'm using Terraform 2 to do provisioning. I don't know if anybody uses HashiCorp Terraform, but it's a great tool. Okay, it's still going. All right, so back to this. Maybe, cool. Okay, so a couple resources here for you guys. I believe these slides will be made available after this for you guys to take a look, so don't feel like you have to write this down or take a picture with your phone. There's a GitHub repo with all the code and everything that I just walked through, and some samples and some nice documentation, as well as a blog post that, again, walks all through this. So this will probably be helpful for you. I see a couple of people taking pictures, so I'll give you 2 seconds. Okay. All right, next thing is we're going to talk about using Amazon EC2 run command with Chef. How many people have used or heard of run command? All right, it's about what I expected. Okay, run command is actually a pretty sweet service, and I think Windows users in particular, you guys are really going to like this. So run command is powered by an agent that runs on your servers or your instances. And as the name implies, you can use this to run scripts or commands on Linux and Windows servers without the need to SSH or have any WinRM access to those instances. So you need no remote access for this. That's kind of the magical part. You can also now install run command on your on-premises instances. This is as of about 2 weeks ago. So as long as your OS is supported, there's a few flavors of Linux and Windows, you can actually install the run command agent on your on-premises instances or servers and manage them through the same exact AWS console you would use for your EC2 instances. Same APIs, SDKs, everything. And so run command is kind of an interesting solution for, again, running commands on servers where you may not have remote access, or you want to move away from managing remote access. And you can use it to maybe replace some things that you would normally use knife to run for. So I'll show you a demo, I'll show you how it works, and then we'll talk about maybe some possible use cases for it. Okay, let's see. Let's see if this ever went away. Oh man, it didn't. Okay. So first thing I'll show you is the run command console. So there's a few things. Oops, not again. Okay, that's better. So this is the run command console. So there's a few things you can see on there. There's a command ID, the instance IDs the commands get run on, and then a document name. You can see like the status, requested date, all this kind of good stuff. So the first thing I'll talk about is the document name. So this is kind of run command terminology for the set of commands you're actually going to run on an instance. So every document that gets run contains a set of commands. And so there's documents that AWS provides, and you can write your own documents as well. And so when you click on a command, you can see there's a description here. And again, it's kind of hard to see because the screen's smushed, but there's an output tab as well. And so you can see exactly what happened. If you click view output, you get a nice little snippet of some standard out and standard error, and you can see what your command did. All right, so let me show you a command document. And documents are just JSON files, pretty simple. There's a couple required keys, one of which is schema version. I believe 1.2 is the only schema version right now. And all the parameters and everything is documented on our site. So I won't touch on everything that's possible, but just a few things that I have here. Of course, you can give a description for your document. And then there's parameters. You can think of parameters like variables, basically. And this will come in handy in just a moment when I actually show you the console when you run a command. So you can pre-populate with some defaults. Oh, I should call out too, this document, this run command document is for used on a Linux server to install a Chef client. So basically bootstrap Chef client on a Linux server. So I'm saying the version that I want Chef client to install, a bucket with some files in there like my client RB and a certificate to actually authenticate to a Chef server for the first time, an initial run list, my Chef environment, all that good stuff. Okay, so you see here at the bottom there's a runtime config key, and really the most interesting thing in here is this run command key in here, which is a list. These are all the commands that I want to run. And so you can see in here, I don't know if this is showing up, yeah, okay. So you can see here I'm doing several things. I'm making a directory, I'm grabbing some things from S3, and you'll see the things here in between the handlebars or mustaches or curly braces, whatever you'd like to call them. Those are my parameters or my variables. And so I'm dynamically grabbing those things, grabbing the OmniTruck installer, and kicking it off with an initial run. Okay. To actually run a command now, you just go back to the console. And again, you could also do this through the SDK and APIs and stuff too, but I'll show you the console. So the first thing you get is your command document where you select. As I mentioned, there's several documents we give you out of the box. Lots of stuff around Windows, installing updates, joining an AD domain. There's a generic one for Linux for just running a shell script that you can pick. And I also mentioned that you can create your own documents and share them. And you can do that either publicly or privately. So let's say you have multiple AWS accounts. You can just share those between those accounts, or you can open it up globally for anybody to install. And then I'll pick my Chef Linux install Chef client, and then target instances. So you'll automatically get a list of instances that you can run this command on. And so this list that they give you back is anything that has the run command agent installed on it and matches the OS of the document that you selected. So in this case, I'm just getting Linux instances with the agent. And here's my parameters. So here I could change any of these. I pre-populated them for speed of demo, so stick in there. And then there's a timeout, and you'll notice there's also an S3 bucket in here. So when I showed you that output tab earlier, that's actually a truncated output. So you'll get like, I forget how many characters it is, but if you want full output, and so this is useful if you want to get crash dumps or stack traces, anything like that, make sure you include an S3 bucket whenever you're running the command. And so this will actually give you the full logs of everything that comes out. And it groups them by like a run command hash and then by instance IDs. So it's organized for you. So I'll click run. And now this is going to go out. It's going to talk to each agent on each of those 2 Linux servers I selected. The agent's going to go and pull down the document that I specified and then execute the document locally. And so, well, I have 3 servers in my Chef server. I should only have 2, but once this runs, I should now have 5, I guess. Or maybe I'll have 4 if Lambda actually ended up running again. So let's take a look and see if they finished. So I got 5. Okay, so I got my 2 new servers in there, and you can see if I sort it by last check-in, which I actually can't do, you can see the 2 towards the bottom say a few seconds ago. So these are my new instances that I spun up with run command. Okay, how are we doing on time? 10 minutes left. Okay. I had a demo to show using run. Actually, let me do this first. I'll talk about a couple use cases for run command, and then I'll switch it over. Okay. So a couple ideas for run command. Again, I have a repo of the stuff that I showed you guys today in the demo. So feel free to take a look at that, including some of the run command documents that you can use as samples and the KMS demo and all that good stuff. A couple other things you might use run command for with Chef that are interesting. Chef Vault to automatically refresh or regenerate secrets when auto-scaled instances come out. So I know this is kind of a pain point now for auto-scaling around Chef Vault. So you might use run command in conjunction, again, with Lambda and CloudWatch events to do that. You might run Chef inspec if you're not a Chef compliance user. So you can trigger this with run command. Maybe run a recipe on a group of nodes at a certain time. Or just generally, again, anything where you don't necessarily have SSH or WinRM access to. Okay, so we actually have a giveaway for an Amazon Echo. And I have a little demo of using run command with the Echo, but I don't have time for it. So I'm just going to leave this here, and we're going to walk around the room with tickets, rather. So if you want in on the raffle, I think you just need to take a ticket. I will figure out how we're going to draw it later. And if you have questions or you want to see the run command Echo demo, just stop by the AWS booth. I will be there all day today and all day tomorrow. Sorry, let's do questions after, only because we're going to have Frank from Gannett get on stage now and talk about how Gannett uses AWS and Chef. And we don't have a whole lot of time, but again, I will be at the booth all day today, all day tomorrow, to ask me any questions you want about anything I talked about or anything else. All right, so welcome to Frank.
Thanks, Josh. I'm Franklin Hansen. I'm a manager on the Platform as a Service delivery team at Gannett. We're responsible for putting together all the platform tools, including our integrations with Chef and AWS for all of our internal developers. If you're not familiar with Gannett, we're a national and local newspaper and media brand. Our national brand name is USA Today, which I think most folks are the most familiar with if you don't have a Gannett newspaper in your area. I want to talk a little bit about how we're using EC2 and Amazon in general, and that's largely for our infrastructure testing pipeline at Gannett. We deliver a little over 500 cookbooks continuously at Gannett, and those are all based on the same pipeline serviced out to all of our internal customers. So the most obvious tools, I think, are the Enterprise Chef Server and Supermarket. We maintain an internal supermarket so that our users can stay in sync for their internal testing without having access back to the actual Chef server itself. All of our CI pipeline is built on Jenkins, and Jenkins itself is tied to a whole suite of tools which we use, which I'll cover some of the external partners we're using as well as some of our internal tools. The partners are obviously EC2, and we're using that in a bunch of different ways. Most common is, if somebody wants to provision a box, we do that on EC2, and that gets bootstrapped. But also, it is the underlying image that gets built for Kitchen EC2 runs. It's what Jenkins itself is running on in a lot of the underlying services. We use Artifactory for gem repositories to shorten the time it takes to download gems from Ruby on the Chef runs. For local testing, we're using Vagrant, and those images are generated using Chef Zero managed by that Jenkins pipeline. Packer for publishing our images from EC2 back to our internal infrastructure. And Scalar, which is our cloud management platform. Scalar sits in front of our clouds to allow users to self-service, creating infrastructure and bootstrapping that again without giving out our actual Chef server keys or IAM resources. So to talk a little bit about what we're testing. We care about several different things. We care about style, both from a Chef perspective and from a Ruby perspective. And we care about unit testing and integration testing. We stay very close to releases on RuboCop and Food Critic for our testing. We've got a few rules that we care about in Food Critic that we don't actually fail on. One of those is avoid repetition of resource declarations. So just as something comes up, it hasn't been an issue for us. So pretty much everything else we fail our infrastructure on. RuboCop is very much the same way. We try and stay as close as we can, which can be pretty obnoxious sometimes as RuboCop changes under the covers from us. But really the only thing we kind of set globally is our line length. From a unit testing perspective, we really try and strive for 100% coverage as our tests roll out, but that's subjective based on what you're actually testing from a context thing, so it really falls down to peer reviews. And it's the same for server spec, really trying to figure out, it's not really code coverage, but understanding what the purpose of your cookbook is and are you actually testing the use cases that you're going to deploy. The other thing we've been working on is building into audit practices. We've worked with security teams to test using server spec some of the configurations for things like SSHD and firewall and SE Linux. We've started looking at inspect to transition that, but that's something that's pretty new to us there. So to kind of glue all these pieces together, we've built up a lot of internal tool chain, and this is borrowed code from other folks, and it's stuff that's been built internally by our team. One of the most important things that's been helpful for us is our skeleton. Skeleton for us is a way to wrap the Chef generate cookbook command. And so it allows us to build the framework for the spec testing, and the style gets dropped on there. We drop a rake file and our .rubocop YAML file, just a lot of the pieces so that developers can stay in sync with what we consider a good cookbook at Gannett. And so part of that is, as I mentioned, the rake file. A rake file for us is our common way to test. We're using bundle exec to manage our gems that are used. And a rake file calls through each of those binaries for our testing. It just gives a common way for us to do that, and it helps us parallelize our tests in EC2. We had a very large problem with once we got to scale with testing our cookbooks, it takes forever to get changes through. So we have a lot of cookbooks with other dependencies, and as we go through that chain to update, we found that parallelizing our test suites in EC2 significantly cut down the amount of time we could build. We're also using a cookbook called Kitchen Test Helper. Kitchen Test Helper has a couple different things that we're doing in it. The most useful for us had been storing node attributes from our chef run. So that means when we're doing server spec tests, we can use the attributes from the cookbook itself to validate. If we're installing a package version, I don't have to hard code the version. I can say, use the node attribute that I'm expecting to validate that it's on there, which is really helpful for things like remote server spec testing to validate images. The other thing it does is it's moved our data bag mocking out of files inside the cookbooks into attributes in the YAML file for Kitchen. This allows us to override a lot easier and have a whole bunch of different data bag values to be used when we're mocking a whole bunch of different platforms. Outside of the tools that we're bundling with our Jenkins pipeline, we also have a script that validates good practices for us on how to deploy those cookbooks. Kind of the bureaucracy of running continuous deployment for us is how are we managing versions? Are you maintaining a change log so that others can consume your version changes? And making sure that there are JIRA tickets for us in the commits is a big thing for us to tie back to, for us to audit where the change came from. We also, like Josh mentioned, are using Lambda to clean up instances that get left behind. In our case, we're not cleaning them off the Chef server because they're part of our Kitchen EC2 runs, so they're being hit with Chef 0. But we still want to make sure that if we have a failed Kitchen run or if Jenkins slave goes offline, that we don't leave a bunch of instances hanging around for us to have to deal with. So that those get terminated with a Lambda script that runs hourly, looking for untagged instances in our case, and cleaning up ones that we know that are no longer part of our infrastructure. So to kind of give you a better idea of our workflow, we've got 3 different pipelines. We have an image pipeline, a cookbook pipeline, and an application pipeline, and all of them work a little bit together. As in each of the artifacts from all those pipelines are used in each other. So when we get to the end of the image pipeline, we're producing an image both for VirtualBox to use testing locally, as well as an EC2 image for our production infrastructure. Those are used in the testing of the cookbook pipeline. When we get to the end of the cookbook pipeline, we end up with cookbooks that are valid for us to go back and validate whether our new base images worked. When we get through to the end of a base image run, we create that in Scalar with that node and make sure that we can actually bootstrap our base Linux cookbooks on top of those images again to validate that what we've come up with hasn't created a bug somewhere else in the system. Our consumers maintain their application pipeline much the same way. So we have an entirely disposable infrastructure at Gannett. So all the things we've deployed in the cloud can be destroyed at any time, and we just build them back up again. And that's been incredibly important for how we're maintaining Chef and AWS to kind of hold that together for us. And that having that be part of the pipeline as they move through means that they are running Chef on every single deploy, and they're running our kitchen provisioning and EC2 provisioning on every single deploy. So I know we've got just a couple minutes left. Josh, do you want to take questions or?
Let's do the raffle because that's probably what everybody wants to do now.